welcome to my channel. If you're watching my channel first time, please subscribe in my channel. So in this video, I'm explaining the very important statistical concepts which is very much essential for any data scientists or data analysts. So it is called correlation coefficient, calculation of the correlation coefficient. So mathematically it is having a lot of importance. So first of all, before implementing this, I will tell you what is the theory behind this. So what is this correlation? So correlation we can obtain if you have multiple quantities. For example, I have two functions. One function is having one data and second function is representing another data. Now if I want to estimate what is the behavior of those two functions, so statistically I want to study the behavior, and what I mean to say is whether one function is increasing or other function is decreasing. So if you want to compare those two functions, generally what we need to do, we need to plot a graph. If you plot a graph, then we will understand whether which is increasing, which is decreasing, whether both are increasing or both are decreasing. But that will take effort, right? So means linear relationship, if you want to find a linear relationship, then ultimately you need to plot the data with the help of the x-axis data and y-axis data. Then ultimately you can compare it. But my intention is I don't want to plot it, because plotting will take a little more time, because I need to create the plots, I need to generate it, then finally I need to compare. So instead of that, the alternative is calculating a correlation coefficient. So whatever the functions, whatever the data I want to correlate, so let us assume I have one data in x, another data in y. Now one data x is generated by one kind of function, then another data y is generated by another kind of function. So now I want to know the linear relationship between those two. So that can be given. Linear relationship means whether both are increasing or both are decreasing, or they are opposite. One is increasing and another is decreasing. So for example, if I took x data, so statistically, mathematically, it is defined like this. So R is indicated, correlation coefficient is denoted by R, where the formula is, so n is nothing but number of samples here. So sigma of product of x into y. So x data into y data, the product, then we will take the sum of all the products, then sigma x, sum of all the x values and sum of all the y values, by square root over again n into sigma x square minus sigma x whole square. Both are different. This is sum of squared x values. This is after summing up we are taking the square of x values. There is a difference between sigma x square and sigma x whole square. Okay, similarly n into sigma y square minus sigma y whole square. So mathematically this is the formula, but theoretical conclusion is that what it represents. So R represent a linear relationship between those two quantities. Okay, so how it represents, for example, see, generally when you calculate a correlation coefficient between any two quantities, now it lies between either +1 or -1. So what actually +1 indicates and what actually -1 indicates, so I will tell you here. So you see this, so correlation coefficient, so maximum value of a correlation coefficient is +1, and minimum value, the least value of a correlation coefficient is -1. So if any two quantities are having correlation of +1, means they are very strongly correlated, means both are increasing, both are same, both the functions are behaving in similar manner, so they are almost very close, the behavior of those two functions is very close. Then correlation is 0 means it is very weak correlation, means one function, so linearly they are not dependent much. Then -1 means they are negatively correlated. Negatively correlated means if one function is increasing, then the another function is decreasing. That is what means they are correlated very oppositely. That is what. Okay, so now 0 means they are not at all correlated, means the function behavior you cannot compare. Means what I mean to say is there is no relationship, or there is no common variable or common factor which is affecting both of performance of both of the functions. So +1 means strong positive correlation, both are behaving in the same manner. Negative means -1 means both are negative, so negatively correlated means one is increasing, other is decreasing. In that manner we have to understand this. Now let us, this Python provides us to calculate, it can provides a direct function to calculate this correlation coefficient. Let us see how we can make use of Python in estimating and calculating this correlation coefficient. Okay, so let us go back to once again Google Colab. So this correlation function is also available in Python statistics library. So first let me import statistics as st, shortcut I'll use here. Now I need to take some x values and y values. For example, I want to generate x values. So x equal to, I will say list of, okay, so I'll use a range function here, a range of let me say I want to say -5 5 comma, let me say plus 5 6 comma, with the help of 1 1 1. So this is what my x. Then I will take y, so where y equal to, again I want to generate y data, so here also I'll use range function, a range of, then I will say like let me start from it is also 0, then I will say for example 15 comma 1. This is how generally I want to take this. Okay, so 1 is having x data. Let us see what x and y. So what this print x I am doing, then print y. So we got a data with us. Now let us execute this. We'll understand what exactly happening here. So first we'll see the data. So the data is x data, y data, both of us we generated x vector. So here x vector is representing one function and y vector, so y values also representing another function. So let us check it. It is executing. We need to wait. Yeah, now you see x data is this -5 -4 -3 -2 -1. So it is started from a negative number and it is moving towards a positive number. Okay, then this is y data is started from 0 and it is increasing. Okay, now let us try to find the correlation between those two. So what I will do is I will say r is the correlation coefficient, so r equal to, I will say st dot correlation. This is what the function that we need to use, correlation of x data and y data. So how they are correlated, that is what I want to see. Finally I want to print the value of r, that is why I'll write print r. So now if I write this, if I execute this, let us check. Yeah, so there is some statistical error. What that error states is correlation inquires both input have same number of data points. So we have taken different data points, so that's why it's happening. So what we'll do is let us reduce this, because there we have only 10, so I will make it 11. So now let us see. Now in this case, because yeah, now you see this, it is, we got correlation as +1. What it indicates, both the functions are giving same result, means they are strongly correlated, they are positively correlated, means x values are starting from less value and it is increasing, -5 -4 -3. So x values are increasing. Similarly y values also 0 1 2 3 both are increasing. So in this case both the functions are increasing, that is why correlation coefficient is like it is completely, we got it as a 1. Now let me make modification here. For example, I will say I will start from +5 and I will end up at -6 and I will change with the difference of -1 -1. Okay, so here I have started with a positive number. Now in this case let us see what the result will be, because I changed the y data. Now you see in y data, so x data is increasing, started from a negative number and moving towards a positive number, and whereas y data started at the positive value and slowly it is decreasing, 5 4 3 2 1, finally it is came to negative -5. So x vector y vector both are exactly opposite, that's the reason we got -1. So they are negatively correlated. If x is increasing and y is decreasing, if y is increasing then x is decreasing, so like that. So it is both are oppositely correlated, this is called negative correlated. We can say they are correlated, but the type of correlation is negative. So if you are getting +1, it is a positive correlation. If you are getting output as -1, it is a negative correlation. Now let me check, let me take some random values, for example. Okay, so what I'll do is, let me take this. Now I'll take a list of values here. So for example 10 comma 10 comma 10 comma 4 5 6. Okay, so now I have same value, equal values. Here in x-axis I have 10 values and y-axis I have 10 values. Now let us see what this gives. So again I think there is a mismatch. So what is the length of this? 1 2 3 4 5 6 7 8 9 10, and that is also generating 1 2 3 4 5 6 7 8 9 10 11. So one more I need to add here, because they should have same length. Now if I do this once again, oh there is, acha, because I took same value. So what I'll do is I will say I'll take random values. Okay, what I'll take is I will reduce the number here first. So -5 to, let me say 0. So -5 to 0 means it will create -5 -4 -3 -2 -1, 4 values only. Now I will take 4 values here. For example 10 20, then 40 and 10, like this. Okay, now 4 values, 4 values. Let us see what kind of correlation we get it here. Again it will give error. Why? Because it is, the problem is coming with statistical error. Both inputs have same number of data points, minus 5, minus 4. Acha, one more I need to get. So 20. Yeah, manually I need to count it. Otherwise I can use. Now you see here, in this case, x is absolutely increasing because it is starting from minus 5, then minus 4, minus 3, minus 2, minus 1. And now coming to y data. So y data, it is random. It is neither increasing nor decreasing. 10, again it became 20, again 40, again it is decreased to 10, again it is increased. Means randomly it is changing. So now here I am comparing x and y functions. So now in this case, they are positively correlated, but the correlation coefficient value is only 0.12, which is less. Means the correlation means that linear relationship is very less. They are not, we can say they are independent. So like this, it has helps in understanding the behavior. So without plotting any graph, if you want to get the linear relationship between any two parameters or any two functions, then we can use this particular parameter called correlation.